Alright, today I would like to demonstrate my data processing for some local weather data that demonstrates the effects of global warming in our local area. So to start out, I found an online JSON file that contained historic weather data for the years of 1940 to 2000. When you are in the pretty print file, this is what the JSON file looks like. I didn't actually need a private API key to access this. I was able just to use this URL since it is open source data. Starting out with my main file, we're gonna look at the JSON file processing inside data processing. So data processing, this is sort of where the nitty-gritty occurs. The first thing that's going to happen is we're going to call, these are our two classes where we're able to deserialize the JSON. So the weather data actually is sort of it's not necessarily an inheritance pattern, but it's this is what's going to accept info from this class in order to deserialize. So, that's going to accept a dictionary of daily weather, and then inside daily weather we have these three individual parameters, and that you can see that structure kind of mirrored through daily. And then inside daily we have time, and this is where the dictionary occurs, time, and then I can scroll way down and show you where the other two data points are. Going down to JSON file processing, we can see that this is a constructor, or this first we have a constructor where we set what the API website is, and then we're also going to create an instance of the API class itself. Showing you what the API class looks like. It's pretty simple. I just have a constructor that accepts a general parameter called API website, creates an instance of it, and then we can also fetch the API data in order to actually get the data to do data processing. Following back to data processing, we see that in the JSON file deserializer, the only parameter we have is the instance of self, and we're going to use that instance of self to make individual instances from our JSON weather dictionary, our weather data dictionary. So we're going to call the data daily, again referencing here, and then inside the dictionary daily, we're going to access the weather data time. From here, this is where Pandas implementation begins. We're going to make a data frame using Pandas, and we're going to make a data frame that consists of date, temperature, and precipitation. Now, for some reason, they call the dates times inside my file, so that's where there might be some confusion there. But really, when they say times, they mean the date of the year. Inside the for the data frame, I needed to convert the date to an actual date in order for the data for Pandas to be able to work on it, because what I really needed from the time is not necessarily all this info. I actually just needed the year, because I'm trying to get annual averages rather than individual day averages. Following that, my average temperature and precipitation, I'm using a group by function, and I'm also using an aggregate function. So I want them to group by the year, and then we're going to get the temperature, and I want the mean of that temperature, and I want the sum of the precipitation per year. Pandas is really awesome in this implication because it's able to do all these merely by by giving them strings, rather than having to actually do the math myself. So go Pandas, and then I'm also going to reset the index, so that way my first index is 1, 2, 3, 4. I'm not that way later when I continue to do some processing. And then this whole function is actually going to return that variable of average temperature and precipitate. The whole precipitation, the whole data frame is going to be returned. That's important because I didn't just want the data frame. What I wanted to see was a graphic representation of this. So if I go to my Google Sheets, this is where I have a different API called, and this is we're going to be referencing my service account key. I can't show this obviously because this contains private information, but just trust it's a JSON file containing my service a API private key in order to access Google Sheets. My scopes are written to the spreadsheets and my Google Drive. That way it can access both. These are some global initializations. And then inside the load JSON file, we are getting the I declare these globals because this file is actually going to be acting on these globals in order to actually give them some values. Because I don't want to share my private API publicly, I actually give the user the option to input a file path to their API, so that way this can work universally. Then we have a try statement that allows us to open whatever the file path is that they inputted, and we're going to store that as f. And then we're going to load that into a variable called info. And then there's some exceptions handlings. And then inside my variable creds, I'm going to use the imported variable credentials, which is imported from Google. It's a Google variable. And I'm going to do a dot from service accounts info, and then I'm going to do my info variable and scopes equals scopes, which is just some jargon in order to make sure that it's the environment set up correctly. Client is going to be a gspread.authorize creds, and that's just this is initializing the client variable, which is going to be used all the way down here. This gives me the ability to act on the sheet itself. Inside the create spreadsheet function, again, we have a global variable designated, so that way we can act on it. And we're going to be talking about in our spreadsheets, we want to open all the spreadsheets to see what we have. And then we're going to check the length of the number of spreadsheets that we have. Now, if it doesn't equal 0, we're going to enter into some logic here. If the spreadsheet does exist, essentially, then we're going to delete that spreadsheet. Then we're going to enter a try statement. If we entered this logic that says, okay, so the spreadsheet did exist, we deleted it, and then we wanted to, or now we're going to create a new spreadsheet, and it's going to have this sort of format. Or no, sorry, this is actually the info that gives you permission to access it, because when the spreadsheet is created, it actually belongs to your private API email, which is associated with your account, but it's not your account. So you need to grant yourself access, and this is where I get the input for the user to grant themselves access through their email. And it'll execute all that. And this is actually the same block of code if we didn't enter this logic in the first place. That way we can execute. Now, I could have made this a function, but since this was kind of made via development, trial and error, I actually found it easier to do these two blocks separate, but they very much could be condensed down to a single function to reduce redundancy. But ultimately, what this is going to do is after it's written all that and created the spreadsheet, giving yourself permission, it's actually going to return a Boolean. And I'll show you why in main here in a second. It returns a Boolean. We'll reference that. And then these print statements are really just kind of key indicators throughout the process that, hey, this is working or this isn't working. Really easy way diagnosis to make sure something does or doesn't break. And then coming down to the actual add data to the spreadsheet, this is where that deserialized JSON excuse me, the deserialized JSON data is being implemented into the spreadsheet. So we're going to make a new variable called spreadsheet, not spreadsheets, and that's going to that's where I'm going to access my client variable that we defined up above, and we're going to open by the key, and then whatever the worksheet key is, that's what we're going to open it by. Then we're going to make a new variable called worksheet that acts on spreadsheet, and I need to get the worksheet. I'm going to get the first worksheet. And then I'm going to clear the worksheet to make sure that there's no data on it. And then I'm going to insert, now this is where I'm actually inserting the data. I want my columns from my data structure to a list. And then I also want my values to inside the list. And then my worksheet.insert underscore rows is showing that I'm going to insert my data at the first position on the list. And this whole logic here is to actually generate the chart or the graph inside Excel. There's a lot going on here, but essentially probably the most notable thing is I manually set the graph or the x-axis parameters, and then I also excluded the year 2024 because we don't have complete data, so it was skewing the data results. And then at the very bottom here, this is just actually building the worksheet, and then automatically opens. Going back to main, once we processed weather processor, and we've made an instance of the JSON filing process, and then we're going to take the average temperature, or we're going to make a new variable inside main that mirrors the variable that weather processor .json deserializer also spits out. And then we're going to call the Google Sheets.load.json to get that data staged. And then, now remember I said that there's that Boolean that create spreadsheets made earlier. If it managed to successfully create the spreadsheet, remember we did all that info with giving access, but it also returned the value of true. If it is true, then we can actually go through and we're going to add the data to the spreadsheet using our now local variable inside main, average temperature and precipitation, which is really just an instance of JSON file deserializer. If it does, it will print success, or else we're going to say the Google Sheet was not created. Moment of truth, show you how this works. So I need to copy and paste my, copy that, or actually I need to copy the file path. Copy path, there it is. I'm just going to paste that into console. It's processing. There is a lot amount of data on here, so it does take a minute. What is my email? And we can see that the data is successfully auto-populated. Again, 2024 is on there, but it's really just scrub data because it's not relevant. And then we come over to our chart, and we can see all this. This is the weather data, and then this is the precipitation data. Something the API doesn't allow you to do that I wish it did, because it actually allows you to really understand what's going on with the chart. If I were to go into series and add trend lines to the data, what you can see is that from 1940 to 2023, we have a positive gain of roughly, if we had to say that this value is about 41, maybe 42, and this value is about 45. So we have about a 3-degree Fahrenheit change in the positive direction over the last 80 years. Same for precipitation. We're starting about 20 inches of rain, and now we're down to, if I had to find a similar data point, to roughly about 17 inches. So we've lost 3 inches of rain per year in Rexburg, Idaho. Now, this is a very local instance of, or a very zoomed in instance of what global warming is doing, but just for this one area, we can see the change. There was global data that I looked at analyzing, but they look at global data a little bit different. They look at it as anomalies, versus this is actual raw temperature data. Actual raw temperature data for global was pretty hard to find and track down, so I resulted to only doing for Rexburg, Idaho, but there's enough data out there to be able to compare what I've done here to what we've seen globally. So just interesting to see what our effects are around here.